Here I'm asked to sketch the graph of the piecewise defined function and determine if it is continuous. So this one has three different parts, and some of you, as we've been talking, like to use the idea of a table or a set of numbers to plug into each of these functions. So I'm going to go ahead and set that one up for you for each of these. So I'll fast forward this in a second here, but we're going to have three different XY tables to help us graph this. So, as I'm going through this, a couple of things to note about the tables that I set up. I want at least three values. You can do more, but I usually like to at least start with three. Then the other thing is that, I want to. So the important thing is that the numbers that I chose for my purple function here, all x values that are less than -2. So all the numbers that are coming up to -2, that's the what I chose. The other thing I know is that this top function, just by looking at it, I know is going to be a line because of the way that it's set up. Same thing with the bottom one here, the blue function. Whereas the red function here is going to be a quadratic, which is going to be a parabola. Just so you know the kind of general shape we're going to see. So in this one, the purple function, I'm going to plug in -4. I'm going to do this math not on paper here, so hopefully I can just talk you through it. So I plug in -4 into here. -4 is just +4, plus 5 is 9. If I plug in -3 times a negative is +3, so that's 8. If I plug in -2, that's going to be +2, which is 7. So I'm going to go plot those points really quick on here. So I got -4, 9, 3, 8, -2, 7. And the thing is about this last point is because I have the less than symbol right here, I'm going to make that an open circle at that point. So that's my far left point, the far left graph there. Next, I'm going to go ahead and plug in these numbers into my quadratic here, which remember, again, I chose numbers from -2 to 3, and I included those numbers because I want to see what's happening at those points. So if I plug in -2 into this function, -2 minus 1 is -3, squared is 9, minus 2 is 7. If I plug in -1, minus 1 is -2, squared is 4, minus 2 is 2. 0 minus 1 is -1, squared is 1, minus 2 is -1. 1 minus 1 is 0, squared is 0, minus 2 is -2. 2 minus 1 is 1, 1 squared is 1, 1 minus 2 is -1. 3 minus 1 is 2, 2 squared is 4, 4 minus 2 is 2. So again, I'm going to plot these points. I got -2, 7. What I notice is that it's got like a little puzzle piece here. I fill in this one here because it lands on the same spot. This helps me know that at this point it is continuous because they connect. What is that? -1, 2, 0, -1. And here, 1, -2. Yeah, good. And 3, 2. And again, at 3, 2, I'm not going to fill it in because I have just the less than symbol. So again, I filled in this circle here because of the less than or equal to. I left this one on the right open because of the less than symbol. Now my last function, I chose 3 and more. So -3 plus 5 is 2. -4 plus 5 is 1. -5 plus 5 is 0. So if I plot those points, looky, it fills in here also. Then 4, 1, 5, 0, and it goes on forever that way. Now, what I should notice is that if I connect all my points here, this is a continuous function because there are no points where I would have to lift up my pencil to draw this function here. So I have a point right here, and then it comes down, back up. That point is filled in. At no point do I have any open circles, so continuous function.